All right, what's going on, y'all? Welcome to another episode of Adventures in DevOps. I'm your host for today, Will Button, and joining me for his second attempt, which is always exciting because, I wasn't sure he was going to come back. I actually had a job one time where at the end of my first day, my boss said, hey, thanks for showing up. It was great working with you. Hope to see you tomorrow, but if not, enjoy your new laptop. But welcoming back to the studio, my new co-host, Warren. Hey, Warren, what's going on?
Oh, thanks, Will. I definitely plan on being here for at least one more session after this one. So
Right.
I think I'll have your, beat by maybe a couple of days. But thanks for welcoming me.
Yeah, for sure. I like that you put a commitment out there, but not a huge commitment. You're like, I'll be here for at least one more episode, and then we'll reevaluate.
I have a whole talk on this, but I think achievable goals are really important.
Right. Also joining us in the studio today, I'm looking forward to this. I have Mike Bowers, Chief Architect at FairCom Corporation, and he's got quite the background here. We were talking before I hit the record button. He's actually got a little bit more experience in this industry than I do, which is rare when you get to my age. So I'm excited about that. He works on high performance NoSQL, SQL databases, IoT platforms. He's the author of Pro CSS and HTML design patterns. And this is super cool. A member of the INCITS technical committee that develops the standards for SQL and GQL, the graph query language. And that's super cool. And then if we have time, one thing I do want to get into here, just from looking at your background, you are the principal architect at the LDS Church. And I just think that's got to be a super cool, fascinating job where you get like those two industries melding together. But anyway, rambling aside, welcome, Mike.
Glad to be here. Yeah, it's fun. You guys are a blast already.
Cool. Well, like I tell my wife, if nothing else, I'm entertaining. No, but thanks for being on the show. So let's talk a little bit about your background. Like I mentioned, you've been doing this for a minute or two, and you appear to have built a lot of your expertise in the domain of databases. So tell me a little bit about how you got to that point.
Yeah, I started out as a software developer and did that over 20 years and had a variety of experiences writing software for consulting firms, and then moved into manufacturing and built software solutions in integrated factories. Like in the silicon industry, I wore the bunny suit going into the fabs, like the Intel commercial, they're dancing in the bunny suit. I'm not in the commercial, but I was definitely in the fabs integrating these expensive $1 million pieces of equipment and learning all their protocols. And then from there, I moved into working at Freightliner and helping them automate their systems. The Sprinter van that everybody gets and rebuilds it so they can do campers out of it. And they're like the Mercedes van, the Mercedes Freightliner van. That van has a computer in it. And I wrote the program, the compiler and the system that programs that whole thing. So that was really fun.
That's cool. And that's got to be some interesting constraints there, just knowing that once that thing leaves the factory, you've got limited options for getting updates or communication to and from it, right?
Oh, yeah. And you got to take it back into the service system and they'll plug it in, and then you can update it with the new electronic parameters. But that's actually a real computer with it's completely the engineer that designed it wanted it to be 100% programmable, which is unusual. Usually you just have these little parameters, turn on the heated mirrors, turn on, this other feature. But he wanted it completely programmable. And so I had to write a compiler, a true compiler that compiles down to byte, machine code to program that thing.
That's like one of those things that I feel like you'd be able to look back later and be like, that was either a really great idea or that was a really bad idea. Do you have
Right.
any feedback on that?
Well, I think the sprinter band's still doing well, so I guess it was a good idea. But my fear was, I'd have a bug in there, and people's lives would be at risk because if there's a bug, bands can crash. So um, that was kind of scary. But no, it's been really good. The vehicle's great, and it was hard. The electrical engineers who were his peers, I was in the meetings with them, and they were criticizing him like crazy because they couldn't understand what he was doing because he made the thing programmable. No one does that. But he wanted flexibility. He wanted a system that would last forever. That of course, if you're programmable, you can then make it do anything in the future. And so, in the meetings, they were killing the project because no one could understand it. But I was getting what he was saying, and I thought, I can do this. I can write the compiler to program this thing. And so he talked to him, and I switched my role from building the web system that would actually send down the electronic parameters. I built most of that already, and then we switched gears to writing the compiler, and I spent a year on that and got that going. So yeah, I think it was good. Be interested to talk to Freightliner and see if they thought it's still good. That's a good question, because they had to pay another firm to take over when I left. I was a consultant, and so that firm has to maintain it. So we'll see. I don't know. But then from there, I went to, I was watching all these people that were DBAs making a lot of money. At the time, back in the 2000 era, the DBAs made more money than developers. And I was also frustrated that Microsoft has shifted their whole tool set, and I had become an expert in certain tools, and they completely pulled us out from under me, and I was frustrated. And I thought, okay, more money. I love databases. I love data. So I kind of decided I wanted to become an Oracle DBA because they made the most money.
For sure.
And so then I decided to switch careers and move into that area. And then it was from there that I got employed at the LDS Church. And I started out as an Oracle DBA. And the person who hired me wanted me to do that for a little bit and then become a manager of the team. And I did that. And then I was a Oracle DBA for about a year. And I managed the Oracle DBA team, the core team that supported, that core team was with 12 engineers, and we supported over 60 database engineers, so DBAs throughout the organization. We had thousands of databases. And then from there, I became the data architect for the entire organization, which is a multi-billion-dollar international organization. So it's a very large with thousands of developers. You think it's a church, but it's an international organization that builds lots of software for its members to do membership-like things. Like one of these systems was an international banking system because the church brings in tithing from all over the world, and it's very important to keep this money safeguarded, right?
For sure.
There is no international banking system that you can just buy. You just can't, that doesn't exist. So we had to build it. So I was the lead on the data side for that whole project to build a brand new international banking system from the ground up. So that's the kind of stuff I did there. And while I was there, I looked into these NoSQL databases. So we brought in everyone you could think of. So this was right during the whole revolution between the SQL and the NoSQL. And so I was right in the middle of all that. And I became an expert in MarkLogic, MongoDB, Cassandra. And then we had a bunch of, and of course, I had Oracle SQL Server and a MarkLogic, which is an XML database. And so those databases were on my team, and I was the architect for helping people decide which databases to choose. So I became really good at each of those technologies and supporting them as a developer. Right. As a developer, why would you choose one of these databases? And I advised the whole, like I said, we had several thousand developers. So I was advising them on which database do you want to choose for your next project. So that's where I went to conferences. I started presenting at conferences, and that's where FairCom saw me and they go, well, we want you to become our chief architect, because FairCom builds, as for 40 years, has built a database product. And they're fundamentally, FairCom is a NoSQL database, but it has SQL capabilities, and they wanted to make their NoSQL features more modern. They had a 40-year-old ISAM technology, which is actually amazingly fast and efficient, but very hard to program. And they wanted to modernize that. So I was brought on board to turn FairCom DB into a JSON database and a SQL database and an ISAM database at the same time on the same data. So you could have 3 APIs that are completely different on the same data and give you 3 advantages. Like the SQL is universal standardized, works with everything. And the ISAM is super fast, bare metal. A record on disk is a record in memory in your process, no layers in between. Nothing can beat the performance of that layer. It's just you have to program it. You have a lot of programming to do. And then I added a JSON layer so you can query it with JSON and get data back as JSON. And it's the same data you would get in SQL, the same data you would get in the ISAM. So that's what that for the last 5 years, that's what I've been working on. And we're delivering here in March a brand new version that has the full JSON capabilities like Mongo or Couchbase, plus these other 2 layers, which with Couchbase has a SQL++, so they have a SQL-like solution. We have a true ANSI SQL solution. FairCom does with the JSON, with this low-level API. So when your queries can't get fast enough, you can go inside the machine, inside the engine with that ISAM layer and get incredible performance. And I'm not exaggerating when I say faster than anything else on the market. I got a machine doing 1 million inserts per second. And Oracle would, and I tuned Oracle database. I built Oracle Exadata replacements at the LDS Church. I designed those and built them faster than Oracle Exadata runs using the Oracle database. So I know what speed is. I know how fast Oracle can go, and this blows Oracle away. It's just the level of programming you have to do is about four times harder at that ISAM layer than SQL is.
So the underlying data is the same in any case. It's just you choose which of those 3 options you want to use to get the data.
Exactly.
Wow, that's pretty cool.
Yeah. Yeah, it's so fun. The JSON is I love the document database world. You know, I as a developer, I was a developer first before I became a DBA and before I became a data architect. So I love building software. I love doing it quickly. And I hate to spend days on the low level stuff, twiddling, reading the spec and figuring out, okay, well, that bit's the one that makes it work. The JSON changes everything. You get up and running in no time. You're building solutions so fast. It's so simple. And it still has the core engine speed of our core ISAM. It's just, it has the translation layer to and from JSON. So it's fast and it's easy and it's fun. So, JSON is one of my favorites. Of course, but yeah, I love SQL. Like I'm on the Insights committee, like you said. I part of the Equal Standards group. The SQL is a great language, and we're enhancing it like to do more things. And GQL is a graph query language, right? So we're enhancing that. And so I really am a fan of those technologies. But it shouldn't be one game in town. Your database shouldn't lock you in to just, I'm a SQL database, that's all I do. Or we're even stranger, I'm an ISAM database, which is what FairCom has been for until now. And then, of course, the JSON is well, Mongo says, well, I'm a JSON database. That's all I really do. You have the best of all worlds.
For sure, yeah, because each one has its own strengths and weaknesses that are one of those is going to line up with what you're trying to achieve better. And that just helps it has a potential to help you build more quickly and actually focus on what you're delivering to your customers rather than focusing on the technology limitations.
Yes. You get that scenario where, okay, I want SQL for most of my stuff because I can write those queries fast. I can join my data. I have flexibility. I know I can achieve any kind of functionality in SQL. It just may not be super fast. And then you go, but what about that one query? And there are times when I'm in Oracle, in that big banking system I was talking about, we had a query that ran for 2 weeks because they had so many billions and billions of records churning through them and making reports. The thing ran for 2 weeks. And so I had to go in there and I write low-level functions to really tune this and that. And we spent weeks tuning that query. Finally, we got it to run in 4 hours. But it was a
Oh, wow.
massive effort and I was thinking about this. If I would have had the ISAM engine, that would have been a day of work, and I would have had total control, and I would have got it 10 times faster. It'd have been 40 minutes instead of 4 hours, from 2 weeks. So that's the kind of when you need to get into the engine and say, I know how to make this fast. I know what I need to do. Just get out of my way, SQL. Let me do it. And it's really hard in these SQL databases to go down there and do that. So yeah,
sure.
you use the right tool for the right job on the same data makes a big difference.
What I'm hearing is you left the Oracle world and went to the NoSQL world, and it's better. Like, this
Yes.
sum it all up there.
Well, that's true. The SQL does things that the NoSQL can't do, and that's really important. The NoSQL world threw the baby out with the bathwater when they said, "No, we don't need ACID consistency." Well, actually, I know the president of MongoDB, not the current one, but the one previous one, and we met a lot and talked, and he says, by the way, don't tell anyone. Of course, I guess I'm telling everyone now because he's gone. But they go, we know we need to be ACID compliant. We know we need to build. It's just hard. It's really hard, and it slows us down. And so we're just telling everybody, you don't need that stuff. It's eventually consistent. It's awesome. And it's, eventually good in terms of consistency. But eventual consistency is a euphemism for never consistent. And if your data is not consistent, that's not a good thing. It means you write a lot of code to compensate. Now, there are some use cases where it is good. So don't get me wrong. There are some use cases eventually consistent is perfect. Those are the exceptions. Most of the time, you need consistent data. Your customers expect when they put something in to query it and it comes back. And Mongo wrote all kinds of workarounds to make a lot of illusions happen. I'm not saying it's a bad product. I'm just saying that when you need consistency, it's really hard to get it in a NoSQL database. Now, FairCom is different. Our engine is at its core consistent. And then if you want to relax that and go inconsistent, I'm going to use the less fun term, inconsistent, the less is eventually consistent, then you can. And then your trade-offs. So I think it's good to have an engine that you really can tune to go where you need it to go. But the other thing about SQL that they threw out was the ad hoc queryability. Now, Mongo kept a lot of it, but a lot of other databases threw that one out. And then they said, well, we don't need joins. Well, that's the dumbest thing I've ever heard. You can't denormalize your data to put everything that you ever possibly could to query and put it into one thing. If you did, you'd have the entire database in one JSON document. Let's just make a whole database in one JSON, and we could query the heck out of it any way we want. Yeah, but that won't perform. You'd have whole database level locks like Mongo used to have. You need to break your data into pieces. You need customers to be separate from orders because customers are not orders, and orders are separate from products because they're not the same thing. And you need to break them apart. As soon as you break them apart, then you have to join them. And so SQL is fantastic at joins. It has all these great join technologies to bring the data back together at high speed. And developers have forgotten that. They forgot because it's under the hood. It's invisible in the SQL engines. They just think, oh, yeah, you just go loop through and join it by hand. You realize how much code you have to write to do that. And then it's slow because you don't get the cool algorithms like the merge join, the index, the hash joins, the index joins, all these really cool technologies that speed things up that SQL engines have built in over 40 years of tuning those things. Developers don't even know what they are for the most part. So they don't even realize what they're missing. And so what you need SQL for those kind of things because it's good at those. But you need NoSQL for other kinds of things like JSON for the simplicity in development and for the flexibility. JSON is not so rigid. You can add new things as you go. But there's always a caveat with you add new things as you go. Let's say you put them in some documents, some properties in some documents and leave them out of others, and you run a query. If the property's not there, the document doesn't show up, and now your queries aren't useful because you're not getting everything. So you need some schema level protections in JSON to say, I'm querying on this property, you better have it there, and you better index it. And so it's more than just, let's just throw everything in a bit bucket and hope it works, which is how NoSQL markets itself.
Right.
But you can't just do that and expect your app to work. So that's why I'm a big passionate person. And it's not because I work at FairCom. I came to work at FairCom because I'm passionate about, you need multiple models. When you need consistency, you need it. When you need less consistency or eventual consistency, you need it. When you need SQL and joins, you can't get with that. You need that technology. And when you need JSON and need flexibility, you need it. So why not have an engine and a model that can do all of those things? And that's my dream, because I wasn't finding it really anywhere. And when FairCom recruited me 5 years ago, this is what I wanted to build. I've been wanting to build my own NoSQL database for the last 15 years. And so I went, this is my dream job. I get to design and build my dream database. So, and we're releasing the first version of that database like I said, in March. So I'm super excited about that.
I'm thinking to like the cloud providers and what they're offering as far as NoSQL and the common cloud providers, databases and SQL ones. And I get the sense that the NoSQL ones are always cheaper and easier to get up and running and start integrating with. And I'm wondering how much that encourages developers around the board, engineering departments, even startup companies that grow to eventually make them the primary use case for whatever sort of data they need to store. And I keep thinking, well, maybe if we want SQL to still have a world, like where is the cheap to run, very, very easy to spin up straight away? Like, where is that?
Yeah. And Oracle is the most complicated, hard to learn technology ever invented in the universe. I'm not exaggerating. SQL Server is easy. Microsoft SQL Server is a beautiful, easy piece of cake. And Postgres is kind of in between Oracle and SQL Server because it's open source. And they have all these PhD students at Berkeley just adding new features, and it's ad hoc and it's not really organized well. So Postgres is harder than SQL Server. Oracle, though, is just a nightmare. I've never seen things so complicated. So yeah, where is the easy SQL database that you could just stand up in the cloud? I mean, you could argue SQL Server might be that database. But then what about the NoSQL, right? The NoSQL databases are so specialized, with a few exceptions. Like you take Amazon, they have DynamoDB. And DynamoDB is really a key value store that it's all about the key. You can have a hierarchical key, and if you can segment your key properly, you can query down inside your key and get subsets of data. You can have secondary indexes, but that's really just another database under the hood with doubling your cost for every secondary index. And, by the time you look at really doing that for real, like, how many indexes do I have in a real database like Oracle or SQL Server? I have thousands of indexes in a real application. Well, let's see, can you imagine the cost of I had 1,000 copies of my data in DynamoDB just to try to do the same kind of thing? It's just ridiculous. So DynamoDB is a good example in my mind of a specialized database that's good for certain use cases, like user profiles. If you want to get user profile data fast and you want guaranteed response times, I want to look up, Warren, I want to get your data now. Boom, it's there. Will, boom, it's there. So that's DynamoDB. That's why they invented it for their own Amazon.com. It's good for those use cases, but that's not what you build an app on. I need an app that needs to grow with the company. I have yet to see an app that said, oh yeah, here's the specs, they're perfect. You build it in 6 months, we'll never change it, we'll never evolve it, we'll never have another use case. It's the exact opposite. You're tweaking that thing forever, and then the customer comes back, oh, I didn't think about this. How do you get customer, I want to go run a query that gives me all the customers that made these orders, where the customers were over 40 years old and the products were Oreos, and the orders are made last month, and you got to join that data together, and you got to filter those three pieces of data and bring it all together in a filtered way. And you're like, I can't do that in DynamoDB. I didn't denormalize my data properly to answer that question. Sorry. Let me go copy all my data and then put it over here in that other specialized database. And now And customers do this. I mean, teams do this. Like there's one of our customers built a cloud solution. They had 5 database technologies in Amazon that they thought this would be great. We'll use these specialized databases and we'll build each one. We'll spread the data across them. The cost of that application is so high, no one will buy it. So their product uses FairCom. It's super fast. The cloud version with all these databases is way slower, so expensive, no one will buy it. They're looking at putting FairCom in the cloud just to run their product in the cloud because you don't have the complexity or the costs. It's so simple and inexpensive. So yeah, I think it's important to keep all those things in mind when you build a product. Complexity is your enemy. And that's what the cloud makes you do is complex solutions. I'm not anti-cloud. I'm just saying the salesmen in the cloud want you to buy 5 databases. They want you to spend up all this because they make a fortune off of you. Because they think that's the way to go because it meets their financial, it makes them rich. So it's great for
sure.
them. But
Yeah,
you want simple.
and not only do you have like the cost of maintaining those 5 instances, but like the ETL and the data transformation for replicating that data is not a trivial task. You have to pull the data, make sure you're getting the correct data and making the right transformations to it, and then writing it to that new data source and verifying that it's there. And like the maintenance and overhead of just keeping that process alive is a dedicated team.
It is just to write it. But then I love the DevOps angle of the dedicated team to keeping that alive is people are so expensive. You don't want to hire me to go build your systems unless you're going to put me on a very productive environment because I'm super expensive. And now you're going to say, now, Mike, you're in DevOps. You need to keep this complex 5 database system alive. And think of all the breakpoints. You've got network connections between 5 different systems. Each of those systems typically in the cloud is sharded, so it scales horizontally. That means multiple servers in each database that have to be kept running. And you say, oh, well, Amazon will do all that for me. Well, they do and they don't.
Right.
They keep it up, they patch it for you, but making it work, troubleshooting the problems in your application across all those systems. Oh, DevOps, the developer can do all that. Well, the last thing I want to do as a developer is maintain infrastructure. As I don't want to support that stuff. I want to throw it over the wall and let those guys do it. But now, nope, DevOps developer, you are on call. You're going to go fix it. You're going to go maintain it. And we're going to do that to you because we want you to build a simple, maintainable solution. But that's not possible in the cloud unless you switch your paradigm to something like a FairCom database where you say, I'm going to get a tool that gives me it's not just a Swiss Army knife because that gives you the wrong idea. It's like a bunch of tools. It's like, well, you don't even have the right analogy. It's 3 APIs over the same engine, right? It's not like 3 hammers. Like Cosmos DB is 5 hammers. You think you're buying one database engine with 5 APIs. No, every time you put data in one of those engines, like their NoSQL engine or their SQL engine, it's completely separate engine with the data separate. It's a marketing gimmick to say it's one database. No, it's a bunch of different databases where your data is spread out all over the place. So having a real database with multiple APIs on it is sort of like a Swiss Army knife. You get the best of all the above, but it's one engine, which a Swiss Army knife's not that way. So it's a bad analogy.
Yeah.
But
so you mentioned earlier that earlier in your career, like the DBA was the highest paid member in engineering. And I remember those days, everyone wanted to be a DBA, and the DBAs had this almost limitless power. They could stop a production release in its tracks and not tell you when they're going to release it. And the entire company was like, oh, well, okay. But they did a lot of work. They did add value because they were answering and designing for a lot of these problems we've been talking about so far. But when I look around today, I don't see DBAs anymore. And I know that there are still some out there and some companies still have them. But for the most part, there are no DBAs, but those problems still exist. So what are the things that as DevOps and as software developers what are the things that we should be thinking about, or what are like the high level thumb rules we should be using to avoid making us really wish we had hired DBAs?
Yeah, I think the NoSQL movement was really the no DBA movement at its core.
Right.
I totally get it because I when I was at Freightliner, we had a DBA. This person, she was I'm gonna say she's the Nazi DBA. I mean, it was just a nightmare. You try to go and you give her your schema, and she goes, "Nope, nope, nope, go fix it." Well, what do you want? When you make it right, I'll approve it. Well, why do you when you make it right? Like, see, then you go, well, what is right to you? Because it was right to me, so I go tweak it again. Finally, at one point, I said, you know what? She's disapproving every single thing I'm doing. And I know I'm not doing a bad job here. I know the rules of normalization. I know all this stuff, and I had normalized it beautifully, and I also tuned it for performance. And then then I realized, you know what? She is wanting simple. She wants one bulletproof schema that will work for any kind of data, anywhere, at any time. And I thought, I know how to do this. I'm going to build a database within a database. So I designed 5 tables that if you use it just right, you could put any data without ever calling her again. I showed this model to her, and she goes, perfect, approved. Because I would never have to go back to her again, and she didn't have to talk to me again. And it was like, this is the stupidest, most horrible thing ever created. This is the anti-pattern of all data design. So yeah, so this is an example of why developers are like, okay, this is a dumb DBA creating really bad designs, breaking all the rules because she doesn't know any better. And it was really sad. But that's the kind of stuff like I'm free now. I'm a developer. I can just build my app, no DBA to get in my way. But to your point, we lost a lot of things. For one, the developer lost a DBA to take the heat because the DBA sits between the infrastructure and the developer. And the first thing an app has a problem, the developer just points to the DBA as your fault. They always do that. And then DBA points to infrastructure, it's your fault. Right. But usually it is infrastructure's fault because storage goes out or some network thing went wrong. But sometimes it's the database. And a lot of times it's the app itself, so it could be anywhere. But the DBA is right in the middle. You take the DBA away, guess what happens? The developer is on the hook for everything except for the infrastructure. And the infrastructure guys are worse than DBAs to deal with. It's not my storage system. I don't have any problems. I had one time I had so many storage problems at one place I was working that we had to hire a $10,000 per consultant to come in and run his scripts on the system to prove it was the storage array, because the storage array guy kept saying, no, it's not my problem. And I knew it was the storage. So we paid $10,000 to prove it was the storage to get the problem fixed to get our solution built. So yeah, now the developer has to do that. The developer doesn't even know what IOPS are. The developer doesn't even know what latency is. I mean, how in the heck are you supposed to get a developer even talk the lingo of the infrastructure folks to figure out a problem? So you take the DBA away, you're asking for all kinds of headaches and problems. And then there's data. Data requires some structure. It requires some forethought. And a developer lives in the now. It says, how can I get this feature out the door today? How can I crank this code out as fast as possible? Let QA get the bugs out, Well, that last thing they want to think about is, how do I structure my data to survive the test of time? As my application ages, I'm gonna really have to rewrite everything if I don't design this data well. A good DBA, not the one that I had at Freightliner, would come back and say, how do we make it bulletproof but not over designed? It's that sweet spot. And most developers don't understand that. And so they just crank it out, and then they're rewriting and rewriting and rewriting. Their companies pay a fortune for these developers to rewrite it because they didn't have forethought. And Agile just makes that worse, because Agile's like, crank the feature out this week, our sprint's done, get it out the door, show the demo, show the UI.
Absolutely.
Well, the UI doesn't have the data structure in it, so no one sees that or cares about it. Now, before the Agile people get angry at me, they would say, well, that's not true Agile. And I agree with them, except for every company I've worked for that does Agile doesn't do true Agile. They do what I just said, crank it out, get it out the door, show the UI. So there's reality.
Yeah, for sure. Yeah, I think if the excuse is is always, well, that's not the pure implementation we designed, then maybe that's a problem with the purity of your design.
Yeah, exactly. Yeah.
Now
So
I'm wondering.
yeah,
I'm
go
sorry.
ahead.
I'm just, I keep going over this in my head. Like, I wonder if something regarding how we treat databases today and the separation of ownership, maybe in this regard, has DevOps failed us?
Yeah, I think we need balance again. I think agile and DevOps and some of these new and the NoSQL trends, which threw the DBA out with the bathwater. You know, I think that is went too far. I think
Hmm.
I'm not, and in fact, some companies are bringing back DBAs for some databases like MongoDB and Cassandra are so hard to maintain. They hire full-time people. They don't call them DBAs as much, but they're administrators to keep the system running because Mongo is pretty hard to keep running, and so is Cassandra. In fact, my last job, we hired a full-time person just to reboot the Cassandra database every week. Because, and
Wow.
it's not just
That's,
the database is a whole bunch of servers. By the way,
yeah.
Cassandra is super expensive. If you're going to go down to Cassandra, you better really know what you're doing because that's my least favorite database of all time. Because DevOps is a nightmare in it, and it's so complicated to design. It takes you 10 times longer to build anything because you have to denormalize everything because you can only query data in one table. Or you have multiple tables, they're wide column tables, but you can't join. So you're basically saying all my possible queries I could ever do have to match one table. And we just talked about that earlier. You have to join, but because you can't at Cassandra, it drives you crazy. It took us 5 years to build an application that you could have built in 6 months in something like FairCom DB because Cassandra's limitations. And in that database, we had hired the guy just to reboot all these servers in the cluster once a week. His job was to run these scripts to reboot them, make sure they came back up. And nothing went down in that overall cluster database, but the servers themselves were going down and back up because Java has a garbage collection and Cassandra's written in Java. And so when that hits, your database performance just tanks. So you have to reboot the server to clear out the garbage collection engine in Java just to make the thing run. So I was like, oh my gosh, that's why there's so much marketing hype around NoSQL, which is the promise of a developer owns their world. Well, when you own the world, like you're saying, Warren, it's kind of the death of DevOps because developers don't want to be that involved in the ops side, in the administration side of anything. And so they don't. And it's pulling teeth to get them involved. So yeah, I think it's a real problem for DevOps to not have database specialists. It's not like we have front end in the developer world. We have front end specialists and back end specialists. Your back end specialists are now the DBAs. They
Right.
need to really know your data. So I think that's good but you got to realize your back end specialists really need to know your data engine and think about data. And if you do that, I think you're going to be fine as a company. And then the front end guys will never do DevOps because they're just the front end app. So the back end, your back end engineers are your DBAs. They're your DevOps people. So hire data savvy back end engineers, and you'll be fine as a company because they'll make good decisions.
I feel like this is a hot take, but maybe it's if we're always using a database where we need to hire an additional person in order to figure out and run it effectively, has that database technology failed us? Like, no one should be using Cassandra if it really is true that we have to hire people to manage that. And I feel like the promise of the NoSQL, as you pointed out, is that you can have the usage of those databases by engineers and run them without hiring an additional person. I mean, how do we rectify that in the world where we stop using these technologies, where you have to hire a DBA or whatever the new term is, system administrator for our database type? Because as long as we have them, people are going to keep falling into the trap of maybe we can use that database of what it promises on the marketing website, but then find out later that we need to hire a really high-paid specialist in order to come in order to actually utilize the technology effectively.
Yeah, I think that's what the whole NoSQL movement was about, was more hype. It's a good thing to compete with SQL. The SQL databases were kind of sitting on their laurels, not innovating enough in real ways that developers need. So NoSQL was great and is great for that. But you can't hide the reality that work needs to be done. In fact, I had a really wise engineer once told me, it doesn't matter where you put the work in a software project, the work needs to be done. So if you move all the work to the developer, great, but make sure that you're going to have specialized developers who know how to do the work. The data is hard. You have to think about co-locating data. You have to think about, do I run the code on a separate server or on the database server? Because if it's a batch job or bulk processing job, the code has to run near the data, because network latency and network throughput is going to kill you by moving the data off the server somewhere else and bringing it back. You need to run the code on the server. So you need specialists who know how data works. And you can pretend, oh yeah, we got rid of that. And that's what the NoSQL movement did. And Mongo's the most successful of all of them, fifth most popular database in the world now, by pretending that these problems don't exist and the developer is fully in charge. It's a brilliant marketing play, totally brilliant. But the reality is now the developer is the DBA. So, and that work didn't go away. And as a developer, did you really want to be the DBA? That's the question you have to ask yourself. If you're a back-end developer, now you're the hated DBA, because you're going to build a web service and the front-end guy's going to give you this. You're going to go, no, I got to refactor my data. That's not going to work for me. And then they're going to hate you. So then there'll be a revolution against the back-end engineer. It's all front-end engineers. I don't know. I'm joking on that, but it could happen. I don't know.
I mean, it's a bit ridiculous, but actually there are plenty of products out there that claim that they are backends as a service, and from some company that is offering this. And you don't have to worry about how your data even looks like or anything. Like, you just throw data at us and we'll store it and do the right thing. And I think the same probably can be said of all of those products as well, right?
Totally. The work has to be done. Somebody has to think about data and the structure and where you're going to process it. And it's a specialty. So figure out where, as an organization, figure out where you want to be. I don't think SQL databases are dead by any means. And I don't think the DBA for those are dead. I think we just need, the SQL is innovating and they're embracing JSON a little more. The SQL databases do have JSON support. Postgres is the best at JSON support, and that's why it's becoming really popular. But you could choose a kitchen sink database like Postgres or Oracle, which has everything you can imagine in it, but none of them are really awesome, except for the SQL engine. Or you could choose a specialty database like Mongo that's really good at JSON, technically BSON, but then but that's not really good at the joining of data. So there's really no perfect solution out there yet. That's why I'm working at FairCom, because my goal is to build the right solution. And to your last point, Warren, about people just want a service, right? The data layer moved from a SQL layer, which traps the data behind SQL, the SQL query language, to a web service layer, which frees the data in JSON. Right. So, FairCom DB, we have the SQL layer, we have the ISAM layer, which we need super speed, but now we have the JSON layer, and the JSON layer is a service. It's over HTTP. So you just send JSON requests over HTTP, and then you get answers back. And the JSON and the answer comes back as JSON. So your data is JSON, your queries are JSON, everything's JSON, and it is a web service over HTTPS. So we provide that now, and like you said, everybody says, well, now we need to transform the data. We need to reshape the JSON. So that's the next phase we're building here at FairCom is the V8 JavaScript engine into our product to do all those fancy transforms on the server side, so you get the data shaped the way you need it. But that doesn't, even though to me, that's a game changer, and potentially it could even replace a lot of backend development. Because we are a web service as well. But that doesn't mean it replaces all of the backend development. It just really simplifies their efforts. But you still need to think about data. That doesn't change the fact you've got to think like a DBA, a developer DBA, where you are thinking about, or architecture DBA. How should the data be laid out? How should we organize the data? How should we model the data so we could build an application that can survive the test of time maybe 80% of the time? You'll never get 100%, but 80% is pretty awesome. But if you use something like, if you don't do any of it, you're going to be surviving 20% of the time on your current design and rewriting 80% of the time. And your company is as a developer, it's great job security, right? And developers actually think about those things. Oh yeah, this is great. I'll be employed here forever because I
Right.
got, but it's not good for the company. So any manager listening to this should really pay attention that developers are protecting themselves by cranking out stuff fast, and they know they have to rewrite it, and their job security is there, and you're paying them the biggest bucks now to do all of that. You should think really carefully about data design and cutting, really reducing costs.
For
That's a
sure.
controversial thought.
They're doing exactly what you've asked them to do.
Yeah, yeah, exactly.
So I want to get your opinion on this, because to me, whenever a lot of the companies I've worked with, they're spending 50, 60, $100,000 a month on Looker and Snowflake, and not for the visualization part of those tools, but for the ETL transformation. That's where all the money gets spent. And
Yeah.
to me, that's not a product. That's a symptom of not having your database design well thought out to serve your business. What are your thoughts on that?
Yeah, well, it may be a symptom of not thinking it through for sure, right? It also may be a symptom of specialization. So when you write an online transaction application and you're trying to service transactions with low latency, right, you're going to design your data model and optimize it for that use case. That's the exact opposite of the opposite optimization you have to do for a data warehouse. The data warehouse, you're going to completely design it a different way. You're going to go into, I like the Kimball model. There's two major warehousing philosophies, Hinman and Kimball. And Kimball is more practical. Kimball says, denormalize your data into a fact table and dimensions. And basically what you're doing is you're saying, you ask the question, what questions will our users ask? What answers do they need from our data? And so you build those answers into the dimensions. That we build the filters for the answers in the dimensions, and then you put the facts in the fact table. So the facts could be like the order cost. If you're ordering a product, what was the order cost? The dimensions are, when did you order it? Who ordered it? Where do they live? What time? All these, who, when, what, where, why, how dimensions surrounding the fact table. You would never build a transaction system doing that because you'd be super duper slow. So what happens is you have to take the data out of your transaction system and then ETL it over or ELT over to your data warehouse, which can be Snowflake or Redshift, or it could be Oracle Exadata. Now there's all kinds of warehouse products out there. And that's the one of my roles at the LDS Church was the data architect. We had a 100-person BI team that I was the architect for. So I have hands-on experience with all this. And we had 100 engineers pulling data out of these transactional databases, restructuring them to answer queries that the business users have. So to write a database that can answer queries in a timely fashion for a business user, you have to restructure the data. So it's actually it's a problem of optimization. It's not a bad optimization. It's that you're optimizing
Gotcha.
transactions for their thing.
So
Gartner,
you're optimizing for two different use cases.
yeah, and
Okay.
that's okay. Gartner for a while there was promoting this hybrid model where you'd have your operational and your analytical in the same database, and the dream was you'd optimize your data for transactional in the SQL side of the database, but then you'd have in-memory column stores. So you'd use your column technology instead of row-based transactional. You'd switch it to column-based in memory, and then you have a columnar view of your row data, but the columns in memory. So then you could query the columnar data, sort of like Kimball's model of facts and dimensions. But that doesn't. The Kimball model works only when you say, what are the questions our customers are asking? And then you organize the data to answer those questions. Think of it this way. Kimball says, I'm going to predefine my reports as data. So all you have to do is just, I want this on my report, this on my report. You're just selecting. I want this, and this on my report. Done. Well, you're not going to take a transactional system and put it in a columnar store in memory and expect that to perform well, because you're not tuning it to answer the exact questions your users have. So it's more fantasy than reality to say I can have a database do everything without data modeling.
Got you.
But could you simplify the process of getting data to those data warehouses. Because ETL is about getting the data, extracting it. And that actually is harder than you think. The E part is one of the hardest part. The transforming part is pretty straightforward once you know what you want. And then the loading it's super easy. So the E part is where the problem is. So if you can get the data, if you can get a database to automatically extract this data for you and push it where it needs to go, then the solution becomes way better. So I built a system at FairCom to do that. Because I know this problem and I wanted to solve it. And so we built what we call it DB Notify. And what it does is every time there's a change in the source system, we automatically send a JSON message over, and we have an MQTT broker product as well. So it's a mission critical MQTT broker. So it's a message queue broker. So what we do is every time a data change occurs in the database, we send a JSON message over our message broker, which guarantees delivery and guarantees delivery once, because you got to have that guarantee in order to get your data somewhere reliably.
Of course.
Yeah. So then any system, whether it's a Java program, putting it into a cache, whether it's a SQL database retrieve, for warehousing, can subscribe to these messages and get the data automatically. So the E part, the hard E part of extracting the data goes away, and you just simply say, give me JSON. And also the data just flows and you have JSON. And now with the JSON, you can now manage the T and the L trivially.
Yeah, because that's a huge trouble that actually a lot of companies I feel like run into, where they have a lot of individual teams with each of their own databases, and then they overinvest in setting up a complex technology like Kafka to ferry messages from those individual databases to align it and push it into whatever their data warehouse is.
And Kafka is a great example. What Kafka's advantage is, it's like a combination of a message queue plus a log, right? So you could query the message log and see everything that's happened, and it's distributed so it scales and all that. But it's complicated, hard to use, and all that. Well, what I did is I looked at that and I said, no way. Can't it be simple? So I said, what is the simplest message queue technology on the market? What as a protocol? And the answer is MQTT. It's taking over AMQP because AMQP is complicated. That's the Advanced Message Queue Protocol, and that's used in RabbitMQ and Cupid and other product and ActiveMQ. It's a good technology. It's just complicated. MQTT has taken over the IoT world by storm because it's simple. You can embed it in a little device, a little sensor. You can put it in big machines, and it truly pushes data. As soon as an event happens, it pushes it to all the subscribers. All the subscribers get it. It's super easy to use. So we took MQTT, and then we said, and I looked at Kafka. Kafka has a log, but it's not really a queryable log. But the log's its secret sauce because it's like a streaming event server with a log on disk. So we took the FairCom database, added it to our own message queue MQTT broker, merged the two together. They're one thing. Added a transform feature to it so we could transform the data on the way in and on the way out of that thing. And now you have a full data integration platform that does ETL super easily. And like Kafka, you can go back and query all the changes. But now it's a SQL database. Remember, FairCom has the SQL, the JSON, and the ISAM layers. So you can get the data out through SQL queries. You can get the data out. So you can query your transaction log or your log of events, your event log with SQL or with JSON. And it's queryable and filterable on the fly, and you can index parts of it. And so you have a not real time, but a very near time dynamic query system on top of Kafka. Imagine if you could have Kafka with a real database instead of just a static log that you could query and filter. And you have real-time push events through MQTT. That's what we built in our broker.
So many words there that I just get triggered on.
I can't. I'm sorry. I'm just geeking out here because I just love this stuff.
You said something really interesting a little while ago about basically needing to hire a DBA specialist, and I'm trying to figure out, like, I'm a CTO of a company. We're under 20 people. Like, that still feels too early. But if you don't hire them early enough, then you end up with a lot of the problems you talked about. So like when in your view do you actually, I mean, it's not at 3 people, right? Maybe that's what you're suggesting is like, oh yeah, one of your first few engineers, like after your founding engineer, you need to have some sort of database specialist. What do you think?
Yeah, I think you need to have a data expert. Now, if they are your back-end engineer who's but truly data expert, understands how the long-term implications of data design, not so obsessed that they stop production. That's what the other old school DBAs did, right? You can't do anything. You can't touch my database. The hard part is you got to hire a person who really knows what they're doing, because like Freightliner hired this one czar that was blocking everything and making bad decisions, right? So you got to, it's hard because you have to know enough about data to hire the right person, but it could be a back-end engineer. It could be that's what I probably would recommend these days. Instead of hiring a DBA, hire a back-end engineer who specializes in a number of data technologies. And on their resume, they can demonstrate, or in the interview, they demonstrate to you scenarios where they designed the data one way using this technology and it caused them problems. They designed it another way and another technology caused them problems. They didn't design it at all and it caused them problems. And they can tell you what those problems are, and they learned their lessons from the school of hard knocks. And then they can say, you know what, I'm not going to do that ever again. We're going to upfront, we're going to be practical. We're not going to over-engineer, over-design, because you'll never get out the door. But we're going to protect you 80% of the time from those problems that you're going to have. And if he could demonstrate that through experience, then you've got a winner.
Okay, that's good advice. I'm actually thinking down that path. Like there must be aspiring, database administrators out there, and they want to hear like, well, what's the first thing to go down this path, right? How do I learn more about becoming the database specialist back end for a burning company? What do I need to know realistically?
Yeah, and I think there has been a market shift, a good one, from another DBA. There's a DBA is stands for several things: database administrator, database architect, and then there's developer DBAs. They're all lumped together in DBA. The administrator person is the one that I'm glad that we're shifting away from. I think it's the cloud has removed a lot of the need for that low level backup your database. Now you still actually in the cloud, you have to configure your own backups, but the technology to do it, the cloud provides. Upgrades. You don't have to do the upgrades. The cloud will do the upgrades for you. So that's good. So the cloud is now, if you get a database product that does this for you, or you go into the cloud, like the FairCom does this for you. We don't require DBA in our product, but we can run on premise or the cloud. But not Oracle requires a DBA just to keep it up and running. So getting an Oracle cloud instance of Oracle would be good for you, because you're going to save a ton of money and the trivial stuff you don't want to. So if I give recommendation for a newbie, don't become the administrator that just knows how to run the script that the book said to run to back up the database. That kind of administrator is not the value add. And that's the kind they're having to add, like Mongo and Cassandra. You have to hire those kind of administrators because the systems are so poorly designed. You got to have a low level guy just to keep it lights on. But that's a dead end career. The value is in the data. So the the DB architect, the guy who, so your backend developer who really understands how to architect the data, so that your application will perform well and grow well over time. That's gold. And so if you have a mind to do that, you have to have kind of a mathematical mind. I don't mean you have to like calculus or something. I just mean you have to have a very logical mind, and you have to look at things logically and systematically and understand practically. You have to be practical. You have to say, okay, this technology does X. If I do X with this technology, I'll be successful. But I know I need a little bit of Y over here to grow the system. How can I make this X system do Y? I need a multi-purpose system so I can do X and Y, but it needs to do both well. You have to make a lot of decisions, and that's where a really experienced. So if you hire a good back-end engineer with like 30 years of experience, 20 years of experience with lots of data work, you're going to be in good shape. So don't skimp on that back-end engineer who does the data architecture. That's going to be gold for you in the long run, as long as they have a good personality, as long as they're not like the no guy. Don't hire those guys. They'll block your whole company and you'll die. They need to be the yes guy who says, yes, but think about this and this and this, and I will help you achieve the goal. I will overcome the problems. I won't just be no. We'll solve this together.
No, I think that's pretty good, spot on advice, irrelevant of the specialty that someone would normally go into. Like, I think irrelevant of whether it's databases or UIs or other backend services, GraphQL databases, whatever have you. Actually, this really got me thinking, and I dabbled in a bunch of different database technologies over the years. And one thing that keeps coming up for me, and maybe this is specific because I always pay attention to security, is it just feels like security plus databases is like oil and water.
Yeah. Well, first off, it's super hard. I think that's why, because your data is the thing you're protecting the most.
Yeah.
Now you are protecting against intrusion, so that's where front hackers can get into a system. But what are the hackers trying to do when they get in? Well, they're going to either encrypt your data and ransom you, or they're going to encrypt your data and steal it. And of course, what are all the breaches about data, right? So you've got to encrypt your data at rest. You got to encrypt it at transit. You've got to prevent the injection attacks to give you backdoors into the database so the hacker can take it over. Security, a good database product, security should be number one. In the APIs and in the system. It should be secure by default. Oracle has a common password that's well known. I'm not going to say it because I don't want to promote this, but and half your DBAs in the world don't change it. They just, sometimes these more administrative DBAs that just run the scripts and stuff, they drive me crazy because they don't know what they're doing and they don't make it secure. And so they don't change things. I remember one database we installed. I installed this database product over 15 years ago at this organization. And they kept the same password I used in that database for 15 years. Finally, I think it was just a year ago, they finally changed it. I'm like, really? I left that company 5 years ago and you're still using my password. My son works there now. And so I actually happen to know, I got him a job on my old team and happen to know they actually never changed it when I left. I'm trustworthy. I'm glad and it was a good password, but still. So this is
You're worried it'll break something, right? If you change the password, production will go down. So I really should be careful. Someone could be using that, in a way that wasn't intended.
Totally true. And then the DBAs are lazy. Everybody's lazy, right? So like, I memorized this stupid, horrible password. I'm never changing this one. But
yeah,
right. We rotate passwords and API keys every time the Roman Empire falls.
Yes.
Well, it's good that the updated NIST, whatever 800B, is now no longer suggesting that rotation actually prevents a certain category of attacks, because the need to rotate means people will forget and have to write it down. So luckily now there is written documentation that may suggest that even doing so doesn't have a positive long-term impact.
Yeah, password managers are super huge. Get one that does crypto random passwords. You'll never remember it. You don't write it down because it's in your password manager and you just use it. And another thing that's a really cool trick that the older databases did not do, because they wasn't well known at the time, was how do you encrypt data at rest? Well, they all can encrypt it. They can use AES standards and they can encrypt it at rest. But where do you put the keys?
Yeah,
that's the big question. And the model that I love the most is you have a master key that encrypts all the keys that encrypt everything else. So that level of indirection is awesome because the customer can change the master key when they need to. The database is constant. A good backend database will automatically rotate its internal keys and re-encrypt data in files. When they optimize a file, you rotate that internal key so that your data, the customer could change it and own their master password, but you don't have to worry about it at rest. Your data is encrypted in a very secure way. And that's very maintainable. So the best databases do that technique. Some of the older ones don't. So that's, keep that in mind. If a database has been around a long time and never really thought through these issues, they're going to have a hard time with security. Oracle does an okay job, but I'm not going to give away all their secrets because I don't want to help hackers out here. But I'll just say one thing: if there was I can't say it, but I'll just,
They don't
can't
need
give
any
this away.
extra help. It's okay. I think they're doing
Anyway,
pretty well all by themselves.
Oracle did a terrible thing and was embedding secrets in places they never should have embedded them, and it was really obvious. And it was like, really? Are you kidding me? And luckily, hackers weren't super aware of this, but we were. And it's like, oh gosh, if they got a hold of this, they'd get the whole keys of the kingdom. I think Oracle latest releases have probably fixed it. I hope, but Oracle's so backwards compatible, they may not have. I haven't looked lately, so I'm not going to go any deeper into that. But like, there are so many holes in Oracle because it's an old system, and they never really thought it through. Um, I would never use. As you can tell, I'm not an Oracle fan, and it's not because it's just because it's so complicated, and complicated means not secure. If it's complicated, you can't cover all your bases and make it secure. So I'm a much bigger fan. If you're a SQL database, SQL Server is much simpler, and Microsoft has kept it that way. And so it's easier to secure it, easier to run it. So from a DevOps perspective, SQL Server is really good. It's not as expensive as Oracle, so it's not cheap. Postgres is, like I said, created by PhD grad students at Berkeley for the most part, and the code. It's the code inside that thing is every developer writes different code styles. Imagine over the last 30 years, every PhD student writing their own little module in Berkeley inside of Postgres. It's a code nightmare. So the complexity of that code base makes that system hard to secure and complicated.
Do they not use root TPMs on the physical devices to encrypt the master key in some way, so it's not actually exposed to the database process, rather than having just some master key that it generates?
That work. If you're a cross-platform database, that depends on your operating system. And so on the database that run on Windows, that focus on Windows as a core platform, they do that, like SQL Server, they can do that. FairCom does that. We use that technology. Running on Linux, though, it's a little different. It's a little harder because the OS doesn't support some of those things as well. And when you want to be a cross-platform database, you have to work extra hard to figure out ways to make things secure on Linux versus Windows versus Mac.
You may be the first person that I've ever heard say that it's more difficult to secure things on Linux. Like, I feel like the HSM with PKS, 11 has no problem encrypting whatever you've got, whatever you need to throw at it. So, that's an interesting train of thought there that is a new one that I'll have to consider.
Well, it's not. I didn't mean to say harder as much as different. The harder part is if you're a company writing database software, you've got to use different technologies and test different technologies on each platform. So that's more of what it is. It's not that Linux is not secure. I don't even want to begin to say that, because actually I like Linux a lot. But I will say, securing Linux requires some specialty skills. That Windows is well known there for hacks and all that stuff. They try to simplify things for their customers, especially on Windows. Windows Server is a pretty good platform, but it's so expensive. You got to go Linux. Everybody goes Linux. It's just Linux is, you're in the open source world and you say, okay, I want to use this feature. Now I'll go find open source. Well, how do I know that open source is safe? How do I know that open source hasn't been hacked? How do I know that it does a good job? Well, there's no company behind that open source. Typically, if you're talking about this kind of low-level code you're just bringing in, it was some developer who's going out there creating something. Then you bring it in, you run tons of tests on it. The work and cost of bringing that in can be really high if you want to guarantee it's secure. So companies don't do that. They just bring it in and hope, because you can't afford to go and let's go run, spend 2 years testing this open source piece of code to make sure it really works well. So you hope. So
I think adding to that is there's the different Linux distributions, because what might be implemented in one Linux distribution might not be implemented in another one, or it's implemented a different way.
Yeah, and everybody runs on Red Hat because you could count on all those features being there. And or of course, not everybody does completely on Red Hat, but the Red Hat is the one that every database vendor is going to run on.
Right.
And then do you support others? FairCom has a history of running everywhere. So we build our software to run on every possible platform you can imagine. At one point, we supported over 129 operating systems at the same time. Well, the world has luckily shrunk down. So now, we still support all the UXs that are out there, HP, AIX, QNX, you name all the Unix stuff. But primarily people want today is Linux and Windows. And on the database world, not so much Mac, but we support Mac as well because developers have Mac laptops. So
Right.
we support and we run it. Ours is extremely portable. We have we written in C, and we wrote it in portable C code so that we can run on any operating system, real-time operating systems, you name it. And not every database can do that. So there's a real cost when you buy for example, MarkLogic was a database that was optimized for Linux. They did all their testing on Linux, they coded on Linux, but then a lot of their customers started buying it to run on Windows. They supported Windows, but it was the step. And so you're like, it was all kinds of problems on Windows because if your engineers are all Linux engineers, they know how to do it there, but they don't know how to do it on Windows, and then you create problems. So for DevOps, it's really important for you to know, is this database primarily a Windows or a Linux database? Or is it really, do the engineers really know both really well and can support both really well? And your code base can run on all of them because it's designed that way. That's a huge issue for you because so many times you buy the product and run it on the wrong operating system for whatever reason, and you pay a cost, bug cost and a support cost.
That's a good point. I mean, I've been a Linux user for a long time, and I just pray that there's some sort of open container initiative compatible container out there that I could just, pull it and run. And if it's not, then I'm on to the next technology.
Yeah. And you have to have containers for most of these products like Oracle. I would never want to install Oracle without a container because that's just a nightmare. My first day on the job, I was sitting next to a guy and I said, "What are you doing?" He goes, "Oh, I'm installing Oracle." And I go, "Well, how's that going?" "Well, I'm on my third day." Third day? Third day? And like, why? I mean, can it be 10 minutes? Can't you just run a script? No. And it was just Oracle's better than that today a little bit, but you're used to minutes, but a container you just pop in and run. One thing about FairCom, because we are real sensitive to this, we unzip and run us like that. You download it, unzip, run, you're going. That's all there is. So we don't even need containers because containers do slow databases down by about 20%. And the reason they slow databases down is because of the storage. The containers don't totally virtualize the storage, but they route the storage through their subsystem, and it causes a performance loss.
Yeah, for sure.
So containers and databases are a performance problem. So if you can run a database just by unzip and run, and you can run multiple instances of the database on the same computer, then you don't need containers. Well, FairCom is one of the only databases that can run multiple instances on the same computer with an unzip and run out of the box story. So we can run hundreds of database instances on the same computer. Oracle takes over the whole machine. It assumes one instance, one machine. SQL Server takes over the whole machine. Postgres takes over the whole machine. That means you need containers, right? Because you need that flexibility.
Yeah.
That's why at FairCom, I really like this core engine that we have because we don't have those limitations of these other databases. And it makes a difference for DevOps, especially. Like MarkLogic took over the whole machine. You can only run one instance on a machine. And this was before container technology. This was about 10 years ago, or more than that, about 12 years ago, or 13. Anyway, we were looking architecturally. We wanted to run multiple instances on the same machine. We had to use VMs to do it.
Yeah.
And that's even more of a hit than containers. And it complicated our whole architecture. If I could have run multiple instances on one machine, I could have simplified the entire architecture, saved us a ton of DevOps time, development time, engineering time, architecture time. But that limitation tied my hands. So something like FairCom, no limits on the architecture, which as an architect, I like that. I could just do what I need to do, get the job done.
Right. Well, there you go.
That was a random stream of it was fun.
That was a lot to take in though. And I think it really highlights how much thought and effort and planning has to go into your database solution. It's not really an oh by the way task, or it can be, but you're going to pay for that for a really long time if you're successful at all.
That's a really important point because when I was working at this church, that large organization, we had we had standardized we had certain databases we supported, like we supported, we had developers all the time that were bringing this under the hood. They would go sneak out and go get a Mongo or get a Cassandra or get another database that we weren't supporting yet. And React was one of their favorites. They'd bring it in, install it, build their app on it, right? And then they go to release it to production. The manager and the infrastructure team goes, "What is this?" "Oh, it's just a database. Don't worry about it. Just install it." "No, we can't. Who's supporting it?" "Well, we are." "Well, no, you have to talk to the database team. We're supposed to support these technologies." So they call me up and go, "Mike, we're using this. Can you support it?" "What? We don't. What are you doing?" And so, like, no, we don't have the people, because every time we bring a database in, you're going to have to train people to really understand the technology to give it the proper support. You just can't throw someone at it and hope that they get the job done. Databases are kind of like a marriage. When you have to be serious about this. You're going to have that database for a long time, and you need to know how to make that marriage work. And it's not just you're going to get married, because if you don't, you're going to get a divorce. But you can't divorce a database. The problem is it's still sitting there. It's still running. It's still causing you trouble, because you can't just rewrite your app overnight. You can't just afford to do that. So this is maybe it's worse than, marriages are great. But I'm just saying databases are worse than marriages. They're just, you're stuck with it forever.
Right. I think this just turned into a therapy podcast.
Yeah. So yeah, you're right. You get just developers are sneaking these in, and then no, it's no problem. And next thing you know, you've got a real problem in your organization. And we had to rewrite so many apps because the app couldn't be supported. And you think about, you're going to have a core team, no matter what database you use. You're going to have a core team that's going to give you 24/7 support on that thing. And so you're going to, and to do that, you can't just put one person on that team or you'll kill them off. It's 24/7, right? And even if they're a Maytag guy, like that's the MarkLogic database, for example, it was like a Maytag database. It never went down. It never broke. So we had two people running over 600 instances of MarkLogic supporting the whole thing throughout the entire organization. But they were still two because they were 24/7 support, and they weren't called. They had to carry the pager, they had to carry the cell phone, they had to have their laptop with them. The stress of the support is always with you. And so you have to take that in consideration when you bring in a technology. You're going to have to get your support people to support it.
That's like the secret conversation. It's like, are you ready? Like, to the development team, are you ready to support this new database you're bringing in? And they're like, yes, we know everything about it. And the only response you can say to that is, you're wrong. Right?
Yeah.
Like, it's like, I don't know what you think is going to be okay here, but you have no idea what you're talking about.
Yeah. Well, it was just to bring in MarkLogic into my last organization, because I was in charge of that whole thing. That's why I bring it up. It took $100,000 project to go bring it in, and get it integrated into infrastructure, to get all the support processes in place, to establish a high availability version and how we're going to support that thing. I ran that whole project, and it was expensive, and it was a real eye opener to me. Like, why can't you just run it? But no, it was a major project, and because we did that, though, we now have it grew like crazy throughout the organization, and it's super successful to this day in that organization, because deployments are just a piece of cake. The maintenance is a piece of cake. The whole thing, because we brought it in correct. But then these other ones like React came in, and not only did it come in surreptitiously and was never supported, the company went out of business. And so you got to think about.
Great story.
If it's a long-term relationship and your relationship dies, you got to think about that. That's a big one.
Database life support. That's a new product, right?
Yeah. Yeah.
Life support as a service.
I love that. When you talk to developers, I had so many arguments. They would say, well, it's open source. It'll live forever. It's open source. It's free. Like, okay, do you realize that there's a company that built this product, and their entire goal, whether it's Mongo or Cassandra or Couchbase or FairCom, if you're open source, it's an illusion. It's a marketing strategy. It's
Sure.
totally an illusion. And your developer, you're completely in fantasy land thinking open source is the answer, because that company has to support it. They have the engineers who built it. If that company goes under, it's not like the community will pick it back up and run. That code is too hard. Database code is way too detailed and hard for just anyone out there. Oh yeah, just get your grandmother to come and go program, get it from GitHub and go change this. Forget it. This takes specialized engineers that spent 10 to 20 years of their life learning this code and learning how it works and learning all the internals. So when that company goes away and those developers are no longer there, they go to other companies. They're working on other things. That database product is dead.
Right.
So can another team, like when Oracle bought MySQL, and then the team that didn't want to work for Oracle left and built MariaDB, right? But the team left and built another company and they forked the code. Can you do that? Yeah. But will they do that? That's a big question. And
You have to
database
decide to
software,
become.
what's
Yeah, I
that?
mean, you're basically becoming the database company, right? Like you're like, oh, you have to be okay with that. You have to be willing to take that code, build it, run it, become the experts of it yourself. If you're going to go down that route, yeah, for sure.
And that's not realistic. It's just, that would be, if you hired me, for example, I could go do something like that because that's the kind of guy I am. But I'm kind of a unicorn. I mean, I'm not unique, but I'm just saying the unicorn herd is not huge
Right.
that loves to get to that level of code, understands what databases really are and what they should do, and knowing that kind of code and make that happen. And you can't replace people like me very easily. So, and you don't want to afford me. I'm super expensive.
Well, that's the
So,
other thing, that just because it's open source doesn't mean that there's a huge pool of talent willing to work on that product for free,
yeah. Oh, yeah. And are even capable of working on it.
right?
At the real engine level where you need to fix bugs. So it's the open source database world is an illusion. Um, and I'm not being negative. I'm not anti-open source. I don't want to come across that way. I'm really not. It's a marketing strategy. Get it in the hands of developers so that they can go build their next product, hopefully become the next Google, or and then they can start paying for stuff. That's the whole marketing gimmick of it.
Right.
But the reality is the open source versions are not secure. They don't scale. They're they they don't provide the tons of the, let's see, the secure and scale are the big ones, but you're also getting tools, the tool sets for the backup, the recoveries, the management. Those are all in the enterprise versions, and those you have to have in a database. The vendors are not stupid; they know that you go open source for so long, and then eventually you're going to pay them. Um, but the developer, it's a total marketing thing to suck the developer in, because we all have dreams of, I'm going to be the next Google. I'll use all this free software to get myself up and running. But in a production environment, when the thing goes down, can you fix the bugs? No. You're gonna immediately get a support contract with the vendor. So yeah, they know that story. So it's a game. Um,
For
just
sure,
be
the
aware
goal
that
is
it
to
is a
make
game.
yeah, the goal is to make it easier to purchase the subscription than to refactor your code to use something else.
Oh yeah, which is not a hard goal to achieve.
Right.
And to me, I call it a Trojan horse. You come in, it's free, it's open source, and then it's in the organization. Next thing you know, wow, this is expensive. Wow, this is hard. Wow, we're locked in. Not too bad. Yeah, so sad. And then the vendor is real happy.
Why
They're
do people
playing the
still?
long game. It takes a
Yeah,
long time for this to happen.
Yeah,
Mongo's
right.
playing a really long game here.
Oh, yeah.
I mean, you would think at this point people would start to realize that this is the pattern and maybe consider that when they're going after certain technologies. But it doesn't seem like that's the case. They're still deluded that the price tag for the source code is there. It's $0 or francs or loonies,
Yeah,
right?
yeah.
I think that our industry is still so new, that we have so many new people coming into it every year, that those lessons aren't being translated. There's too many
Mm,
people for people like us. There's too many people entering every year for us to share our stories with all of them, to keep
yeah.
repeating those, to help them prevent repeating our mistakes.
Well, and
Yeah.
engineers are notoriously bad at making cost decisions. Right? Like, I mean, I know where it comes from. It's, oh, that money would come out of my wallet, right? I don't want to pay that money for it. And they don't understand the business justification and what really goes into the total cost of ownership.
Right.
Yeah, engineers are not good business people, and it's a good thing because business people are not good engineers. I mean, there's exceptions, of course, but the engineer's going to go, I could just build this myself. Why do I could build my own backup solution. I could build my own operations manager. I could build my own security solution. So the engineer goes, I could work my way around this problem. Well, as a company, you're like, I'm not paying you to do that. That's way more money than paying a vendor to do this for me. And how do I know you're going to do security right? How do I know you even know what a backup solution is? I mean, how many software developers know the cycle, the backup schedule you should really follow on a database and how that really should work, the best practices there? Well, 99.9% of developers have no clue. So they couldn't even begin to build that solution. So yeah, developers are it's not just, it's delusion, but it's more ignorance. And I don't mean that they're ignorant. I'm not saying that. I mean, just lack of knowledge. It's
Right.
lack of experience. It's easy to imagine yourself because the developers are awesome. I mean, I'm a developer, Michael, right? We could build anything. And you're like, I could build that. I love building that. Let me build that for you. But as a business decision, you got to really think that through because you want your developers to build your product, your value added product that you're going to sell, not build infrastructure, not build the lower level stuff.
Yeah, and that's a lesson learned through time and experience, the difference between could I build it and should I build it?
Oh yeah, for sure. That's hard because I want to build everything.
Right?
I mean,
I
that's why I
still
work for a
get that one
software
wrong
company.
every day.
And we have this problem at FairCom too because we are in a total engineering shop. So we want to build everything ourselves. And I have to say, you know what? Let's get an open source for that one, but let's vet it carefully. Let's don't reinvent the wheel every time because that's what we want to do in our nature. So let me go build
Right.
that cool thing. So yeah, it's hard. It's managing engineers is hard too because you got to say, nope, you can't do that. You can't do that. We're going to buy this. You know, but you really have to make those good decisions as a software company. Um,
I mean,
and
that's where the fallacy is, though, right? Like we have some backlog of work and we can get through it, right? Like, it's just these 3 or 4 things and then we're done. And maybe we can move on to new things and not realizing that there's a whole list of other issues and tasks that are going to come up associated with managing that technology as you start to build things out.
It's so true. When you're naive about something, you think it at a 10,000 foot level, it looks easy. Oh, backup can't be that hard. Well, then,
You just copy the data to a new location, done.
Right?
Done. That's what Mongo said to do in the beginning. Yeah, just copy our data over. But what if your data is in transition and it's half written to disk when you copy it? You're copying broken data. It's not. You have to quiesce that database so it's not writing to disk while you're copying it. But then, what if your database is huge and you're trying to copy all that data all the time? You'll never get it copied in time. You'll run out of time. So you need to copy what's changed. Well, how do you do that? And once you go down this rabbit hole, but at the 10,000 foot level, just copy the data, piece of cake.
Is there actually a solution to this in the database space where writing to the journal and the actual table can somehow be strongly consistent so that the backup being taken irrelevant will always be 100% consistent, or it's just some small percentage chance that the journal will have data that's not actually in the database or something like that?
Well, in fact, you hit the nail on the head. The idea is you quiesce your database, which means stop writing to the data files, but keep writing to the journal. So the journal, it gets ahead of the data files, but you could copy now the data files safely or make an incremental copy of what's changed in the data files quickly over somewhere else. Then you unquiesce the database. At that point, you mark in your journal, you've already marked in your journal where you started the backup. And then you could copy the journal files over too. So the restoration, you're restoring the data files first, then you restore the journal from that point in time. And then you replay the journal to catch the database up. So that's the technique all the major databases use. But the NoSQL databases start out ignoring the journal completely. and just did dumb things like, we'll just copy the files over here. They've gotten better now, but because their customers have told them, well, your data is corrupt, and so they're gradually fixing stuff like that. But yeah.
That's the difference between the database backup and the database restore. One doesn't care if it's corrupt.
Yeah, right. The backup doesn't care. Oracle spent a fortune on when they do their backup. Oracle's really good about not corrupting data. And so is FairCom. We built technologies designed to not lose the data, because corrupt data is a big problem. So when Oracle is doing the backup, they're reading every block of data and validating it to make sure that all the safeties they built into that block are there. So they're not. So if the field data is off or something, and you can tell, they detect it and then they mark it. So you know when your backups have corrupted data in them, so you can start dealing with the issue. Because the worst thing in the world is you have a backup that's 3 months old, and you just had ransomware, and you got to restore it, and then all that data is corrupted somehow, and you're like, what do I do? So yeah. These are the things that are real.
The answer there is you polish up your LinkedIn profile.
Oh, you're lucky you're not the business owner, right? That's where you're
yeah. DBAs get fired over that kind of thing, or at least depending on what's going on. Sometimes they do, sometimes they don't. But
I mean, I'm mortified that a database company could be walking around out there without having a backup strategy that is actually paying attention to live data streams that are still coming in a high throughput, high volume environment. Like, that just seems for me like, who are you that you think you can just run a database and as a service and walk away? Like, this just seems like a promise that's by default needs to be made.
Yeah, totally. Here's an example. FairCom also has another product called RTG, which is our COBOL modernization solution. Turns out that COBOL writes data the exact way ISAM does. So what we did is we stuck our database, which is that highly available mission critical database, underneath a COBOL program. And the COBOL file handling routines just go to our product directly. Well, the vendors are buying our product to go into their COBOL apps because they can't rewrite the COBOL app. It's millions of lines of code, millions of dollars. It's just too risky. Their whole business, the financial industry, wrote everything in COBOL. Yeah. It's this little known secret. All your favorite banks, are running COBOL programs for all your data because it's
favorite is a controversial word there.
Yeah. Well, yes, or all your hated or whatever. But yeah, one of these big financial companies is coming to us, and they can service all their current customers, but they want to go to tier 1. They sell banking software to tier 1, to tier 2 and 3 systems. They want to go to tier 1, and they're the largest banking software system in the world. But there are certain huge customers they can't service because they run on COBOL and their file system can't scale to what they need. So they're putting our product right underneath their COBOL, which is a plug and play. RTG stands for ready to go, because you just plug us right in under the COBOL engine. You don't change a line of COBOL code, it just works. And then our database scales it. So all the things you're talking about, backup, recovery, COBOL can't do any of that stuff. They back up corrupted files all the time. But what we could do is we now bring the technology to the table to create a storage system, to quiesce the database, create a storage system snapshot, which these are huge, multi-terabyte, like 80 terabyte databases. They're huge. You can't back those up by copying files. So you have to do storage snapshots of those things. And then you can then unquiesce your database and then copy the transaction logs over too, or snapshot the transaction logs. And then the storage system snapshot can restore your data. You save the snapshots. And then if you want to restore it, you just revert to the snapshot, apply the transaction logs, you're back up and running. And COBOL files can't do any of that system. But if you put the FairCom database underneath it, you instantly transform these legacy COBOL systems into modern systems. The only reason COBOL is dying is because it's not the language. Language isn't bad. It's the data systems the data processing was built into the language. You open files, you write to files. That they didn't do what C did and separate data from the language. They kept data and the language together. So the answer is put a real mission critical database underneath your COBOL system, and now your COBOL system rocks roles just like every other system in the world. And, whether it's Java or C# or Go or whatever language, that's all COBOL is a language. Now the data system modernizes instantaneously because we have all the mission critical, scalable features that COBOL needs, but it's under the hood. So that's the power of having a real mission critical database in your solution. Wow.
Yeah.
Well, we could go on forever. Maybe we could come back and talk some more because there's the IoT world is exciting, in
There's
manufacturing.
IoT and I really, just for my own personal curiosity, I want to dig in. I want to have you back on the show and dig in to the LDS work that you're doing, because you've already mentioned that you had like a team of like 60 DBAs and like 1,000 engineers, and that transmitting money around the globe was too slow using existing systems. So you built your own money transfer system. Like, to me, that's
Yeah.
just fascinating. And the fact that it's like the overlap between the church and technology there, I think is just really, really fascinating. So I want to have you back
Yeah.
on just to talk about that.
Oh, cool. Yeah. It was an awesome place because they are so technology focused, and cutting edge, in the technology world, because it's all about the members and making their lives better. And so using technology to do that is super important. So yeah.
That's
And the church,
cool.
yeah, we can talk about that the next episode. That'll be good.
Right on. Right on. So let's move on to picks. Warren, last week we talked about movies. Did you bring anything new this week? Have you been working on it?
I of course had to spend all of my time since last episode actually thinking about what my pick is going to be this time, which is not a movie, so it's slightly more interesting. I think my pick this time is going to be Local Stack, which is a technology that takes AWS offline so you can do local development work. And I think they're doing a lot of interesting things there and trying to build parity for what is running in AWS. I can see as a huge challenge. I mean, obviously, it's not mission critical level of stuff. But one of the reasons I bring this up is because my company just completed a collaboration with them, super successful, where we released an Authoress extension for Local Stack to amp up the security on the authentication and authorization side. So I think great team, awesome stuff that they're doing. If you don't know what Local Stack is and you're using AWS, you definitely have to check it out.
Right on. Very cool. All right, Mike, what'd you bring for us this time?
Well, you said something kind of personal, whatever. So I got my PhD in music theory and my bachelor's in music composition. So I'm a musician at heart. I work technology because that's where the money is, and my mind thinks that way too. I love it. But I play the piano, and so one of my favorite piano pieces, the Rachmaninoff Piano Concerto No. 2. I like so many, but that is just an amazing piece of music. And when I listen to music like that, it's like programming. Now, it sounds weird, but I see structure everywhere. It's layers upon layers of, if you think of object-oriented programming, that's what a music composition is like an object-oriented program with layers upon layers of objects nested with each other in real time with beautiful sounds. And so I love bridging the world of computers and music. That's just kind of the way my brain works.
That's cool. I'd never thought of it that way, but yeah, that makes a lot of sense. Do you have like specific background music that you use when you're working?
Yeah, none. If I turn on music, my brain goes straight into the music, forget everything else. Cause like I said, I got a PhD in music theory. So my brain's an analytical brain. I don't just hear music. My brain is analyzing music. And so it takes over my whole brain. So no, I can't listen to music.
I'm the exact same way. Like there are so many times I used to listen to music while I was doing things, and I would have to take my headphones off so I could think. And I think there's something to this, like people who are driving cars, which are super common, turning down the radio so they know where to pull over on the side of the road. Like so, there's something there for sure.
Yeah.
No, I agree. The only exception, like the only thing I can listen to in the background and stay focused on work for me is Pink Floyd's Dark Side of the Moon. And I don't know why that is.
Like on repeat continuously.
Yeah. It's one of my Spotify playlists, and I just repeat it, and it just plays, but it puts me in flow state. But any other song, and I'm paying attention to the music.
Yeah.
There's something about like just white noise in general that it can be used to stimulate. So, maybe this for you, with your brain waves is just how to get you in that state. It can be anything. And for you, it's this one.
Yeah. Cool. Well, I brought 2 picks to the show today. The first one, same one that I picked last week, Platform Con, coming up. I think it's coming up in May, 5-day virtual conference about platform engineering and all the aspects of that. Luca, who's been a previous guest on the show, he'll be back on the show in March to talk about Platform Con, but some really great speakers lined up there. So platformcon.com, check that out. Totally free 5-day virtual event. And then the other thing, not technical related at all, but recently I put on a throttle body spacer, a cold air intake, and a mass airflow sensor on my truck to improve the performance of it. Bought all of them from americantrucks.com. And it was super cool because you tell it which vehicle you have, and the website updates itself to only show stuff that is compatible with your exact vehicle, so you don't buy something that's not going to work. But then they also have, on every product page, they have videos showing you, how to install it, what the performance is going to be like before and after, where they'll put the truck on the dyno and show you the output. But just a really well done website. So americantrucks.com.
Does it come with the Vision Pro, that you can put that on and see in real time how you're supposed to do it?
Not yet, but that's actually a pretty cool idea. Cool. All right. Well, I believe we have an episode. Mike, thanks so much for being on the show. This has been, it's been information overload in every positive aspect of the term.
There was a lot. Yeah.
There was, man. You did a great job of highlighting the role that DBAs have had, and the fact that need still exists.
Yeah, for sure.
So thank you for coming on, and we'll check in and have you back on the show, because I want to have that follow-up conversation with you.
Cool.
Yeah, I have some burning questions in that area.
Fantastic. I love it. Yeah.
Warren, thanks for joining me. Love having you on the show, man. Looking forward to many, many future episodes. And everyone listening, thank you all for listening. And we'll see y'all next week.